Hello there, welcome back to my workshop. Today we're going to be looking at my latest obsession, which is the Tiny M. And if you know anything about these kits, you might recognize this as looking like a Voron Zero. It's not actually a Voron Zero, it's loosely based on it. You can actually follow the build guide, but it's using parts that are easier to find, especially if you've got older kits lying around, like what I do. So in today's video, we're going to get a benchy going. I've been tuning, we can get it down to 20 minutes, so I thought we would get that going, and then we can talk about the printer, the parts that I've got in here, and the fun that I had making it.
Oi.
So let's get that benchy going, and we can take a closer look at the Tiny M. Let's start with why I decided to build a third DIY printer that would actually be my 10th printer I currently own. It's a good job I'm not married. I was watching Mandic Really's video about the cheap Zebor Voron 0.2 kits, and I think Nero was just starting his V0 upgrades to the V0.2. I was between projects and I liked the idea of building a small printer, but I didn't have the money to buy an actual full kit. I did have a lot of parts that could be used, but looking at the V0, they are based on different sized parts. The extrusions are not the same as 2020 that you will find on most common printers. They also use smaller motors, and I had NEMA 17s. I continued to look around and I eventually found the Tiny M GitHub. This is a V0 style printer that did use a lot of the parts that I already had. So before I'd even looked at the rest of the GitHub or the BOM, I had decided that this was going to be my next long-term project. Anybody that's at the beginning of a new project will know how exciting it is. You have the enthusiasm, you just want to get on with it. So I downloaded the GitHub and had access to all of the STL files. Started printing all of the parts of my Prusa Mark III. I've got Black Form Futura Apollo X ASA and Polymaker Blue ASA. Don't have a good proper enclosure for high-tech printing, but my printers are enclosed. And next to the Prusa is an endif Max. I use that to heat up the area so that the temperature is around about 30 degrees. I use glue stick on the Prusa textured PEI sheets. As long as the glue stick has been allowed to bake on and is totally dry, the ASA prints on there so well. I also took advantage of the new alpha version of Prusa Slicer and set up fan profiles for overhangs. You don't really need cooling on ASA, but I was finding that the quality of the overhangs wasn't so good. So I did set up to have the fan on the minimum amount at all times, with a small increase for the overhangs depending on how steep the overhangs are, and the parts came out looking absolutely amazing. And that took probably a few days to do that. There's quite a lot of parts, but they turned out great. So while parts were printing, I started to gather all of the spare parts that I had lying around. We had old NEMA 17 motors, Titan extruder, Big Tree Tech Manta M8 board, and CB1 that they sent me during their early beta development. If you want to see more details of the actual build, I did 3 full live streams of the build. It goes into a lot more details. Then, as I started to get into the BOM, I was realizing that there were parts that I didn't actually have, and I just ordered them from AliExpress. So I ordered all of the linear rails. It used flange bearings, which were a part that I couldn't really find, and then I ordered a 24 volt bed heater, and thankfully they had a 150 by 150 PEI spring steel sheet. It's not something that I could find anywhere else. None of these parts were particularly expensive, so it was okay to get those ordered at the beginning. Then I started to look at the 2020 extrusions that I've got. I started to measure them out and make the cuts. Unfortunately, while I was doing this, I actually broke my chop saw. I was trying to precisely measure something and it gripped on the aluminium and it snapped the actual frame of the chop saw. This turned out to be not so bad because 2020 that you get on most 3D printers is a V-groove for V-wheels to run in. AMG 9 rails that the gantry runs on this printer is 9mm wide. It's actually too small. It sits in the groove. It makes it very, very hard to keep them flat. So I ended up having to order T-slot 2020. And I did find somebody in the UK that was selling that, but they had a very high minimum order and very expensive shipping cost. So after the chop saw broke, I decided to order a complete new frame. It wasn't that expensive really, but the minimum order and the shipping just meant it was worthwhile ordering all of the parts that I needed. This did save me from having to cut parts, and it did mean that the ends of the 2020 were cut properly and were actually square, which is a big help when you're making a DIY frame. The next big part of the project moved over to my CNC. I have a WorkB CNC from Ooznest, and I can cut aluminium on it quite nicely. Just like on my other printer, I set up a jig and I cut all of the blind holes for the frame. It's very easy to do and it takes no time at all. Plus you can cut them so that they're like an oval shape. It just gives you a little bit of wiggle room. Then I machined my own bed. I wanted one of the beds like the Mandela Rose that you get in other kits, but they didn't do one in a 150 by 150. So I decided to make my own. I do have one small issue, that the magnets that I used were very cheap and they will only go up to around about 80 degrees before they start to lose their magnetism. So I am limited to printing on PLA. But it was a load of fun working out how to recess the magnets and then tapping the holes afterwards. I first tried this on an aluminium plate, but aluminium plate is not good because when it expands, it doesn't expand evenly. And also after heat and cooling cycles, it can do damage. The aluminium can change. So I quickly learned that I needed a cast aluminium plate. These cast plates are actually machined flat, and because they're cast, the structure of the aluminium is a lot more uniform, so when it heats up, it maintains its shape. Basically, it stays flat, and they're machined flat, so you get a really, really nice flat print bed. Another reason that I went with the recessed magnets is so that I didn't add a layer of the magnetic sheets that go on top. My bed is so incredibly flat. It's one of the favorite parts of this printer. I don't need to do a probe or anything. The bed is just flat. It's amazing. So that was another live stream that I did, and again, so much fun learning and working out how to make the actual bed myself. So the build was relatively easy. I'd watched more than enough videos to know how to do it, and you basically follow the instructions from the Voron 0. If you've built a printer before, then everything just kind of makes sense. I did machine a few extra parts. I did the bottom brace for the Z stepper motor. I did that in aluminium. And I was going to do the top part as well, but I haven't got round to it. I've also started working on an all metal bed, but that's ongoing. Here we have the obligatory I made the motion system okay and it moves around nice and freely part. So like I say, if you want to follow along, I did everything on the live stream, including the part when I made a mistake and damaged 2 of the TMC2208 stepper motor drivers. Now let's skip forward and talk about all of the things that I've upgraded since building it. So we still have the Fanta M8 board. I absolutely love it. The way that it controls the fans, you've got 5 volt, 12 volt or 24 volt, so no need for buck converters. It also has 2 4-pin fan ports with complete pulse width modulation and speed readout. I use that for cooling on the back. Absolutely fantastic. Did have some trouble with the CB1 THICC Pi alternative. It was one of the very early ones and it was a little bit unstable. The internet speed was very slow and just I would have random problems when the main cell would just unload itself, and it was causing me so many problems. And I eventually found a used original CM4 module on eBay. Thankfully it was only a little bit over retail price, and so far it's worked perfectly. So we've now got the M8 with the CM4. I also upgraded 2 of the original A4988 stepper motor drivers with TMC2209. That's just on the A and B motors for the motion system. We're still using the A4988 drivers for the Z and the extruder, but they're working okay, just a little bit noisy. I replaced the Titan extruder with a Sherpa Mini. So that's a direct drive and it's using an LDO Motors pancake motor. That works absolutely perfectly. I did have to reprint a new part for that to go on. I replaced the cheap GDS fans that I'd got, the 4010 fans, because they were rattling so much. As it was moving fast, they would just rattle and it was driving me insane. So I brought 2 Delta fans, ordered them from THICC, and that fixed the rattling and they worked so much better. I also replaced the Revo 6 that was using an old cartridge, and I've put in the Dragon hot end. The original spec for the TinyM was using the Dragon, and I brought a Voron edition Dragon hot end, and I upgraded that with some Montech CHT nozzles just to give it a bit of a boost on the flow. I also replaced my old Z coupler with new ones, and also the palm nut as well. So the Z motion system is moving very smoothly now, and overall I'm very, very happy with how the printer has turned out. My upgrades have worked out fantastic, and because it's a DIY printer, I can chop and change as I want. I can upgrade parts as and when I want. If something isn't working out quite right, maybe I can design a new part. Just like I tried to design my own cooling duct to fit a bigger fan, because I was having some issues with cooling. Again, we'll see that in a little bit. And I did do it, and it did work, but it obviously just looks a little bit ugly. I'm sure you'll agree on that. But overall, the upgrades all turned out fantastic. Now we have our fully upgraded printer. I decided to give it a name, and I called it Zippy, which is quite fitting really, because it's actually quite fast. So we need to follow through the basic calibration steps, and I'm using some new filament to me. It's eSun High Flow PLA. It's advertised for printing at high speeds. Not all filaments can actually print at high speeds. I tried printing with Prusament and it was not happy. I had very good success with everyone, and that would print actually quite fast, but I decided to give the Zippy the best chance possible with this eSun High Flow PLA. I am very impressed with the results that I've got so far. So we basically follow the steps through, and I've been using Orca Slicer, which is a fork of bamboo slicer, which comes from Prusa Slicer, which comes from whatever the first one was called. I can't remember. And that actually has some calibration built in. So I did the flow testing, and we printed parts out to check the actual flow. It's based on the quality of the top layer, and then you choose one part and you adjust the extrusion multiplier in the slicer for that particular type of filament. Once you've got the flow sorted out, you can then look at actually how much plastic can be pushed out. So it's not so much how fast it can go, but the actual cubic millimeters per second flow. Orca Slicer has a flow calibration built in. I ran it and I was getting up to 30 cubic millimeters per second of flow before I started to notice some issues. But that was on a very thick extrusion. But I printed it and it looks quite good. Normally when you push black filament especially, you'll see a color change. It goes from glossy to matte, but this eSun, it doesn't look too bad. So then, knowing how much I could actually extrude, I put that and changed it into how fast I could extrude it. And I started with 100 millimeters per second in the slicer, and then using the control panel in Maincell, I kept increasing the speed. And we were running at a slowish acceleration at this time. I didn't want to limit the speed from the acceleration. So I think it was around about 5,000 on the acceleration. And I would print at 100, I would increase it, I went to 150, 200, 250, 300, 350, 400, and eventually I got up to 500 millimeters per second. And as you can see from this picture, it actually looks quite good. The actual extrusions are okay, it's not skipping anything, and I was quite surprised when I saw the screen in Maincell was saying 50 cubic millimeters per second. Now, if you do want to print high, you generally have to print thinner layer lines. So I was testing 0.15 millimeters high on the layers, and that gives you the best chance. If you look at the new Corality K1, I'm fairly sure that they are using a 0.1 layer height to get their 600 millimeters per second print. And I'm fairly confident that my printer could do that. I then pushed it as far as I could, and we got up to 500 millimeters per second with 10K acceleration. And this time I was using the Clipper resonance test, where we've got the X and the Y. So after running this, I could see that there was a little bit of resonance in the printing. Considering how fast it was going, it didn't look too bad. So after running the flow and the speeds, I did the pressure advance, which stops it from bulging out on the corners. That went okay. And I did the resonance advance, and we connect up an ADXL accelerometer, and we can use the built-in functions of Clipper. It measures the resonance, and then it applies a filter to it, and that tries to stop the ringing on the printing. Actually works really, really well, as you'll see later on with the benchy that we're printing in the background. So I'd got my flow, I got my speed, I got my quality. The last step really was that the benchy that I was printing in 20 minutes just didn't look very good. And I was pushing the stock cooling of the THICC just too far. That was why I tried to do that yellow cooling duct earlier on. But I knew that I needed to upgrade the cooling way beyond the stock. Now, if you've looked at other printers that are printing very fast benches, obviously we go back to Albert with his Voron 247, and he has an insane amount of cooling. He's got blowers on the side that blow air across the bed. If you look at the Bambu Labs, the X1 Carbon and the P1P, they also have auxiliary cooling fans. So I decided to look into this, and I actually found that somebody had done a reproduction of the Bambu cooling fan, and I actually found the correct fan on Amazon. So I ordered one, I printed out the cooling duct, and as you can see here, it's a perfect fit. It just fits under the extrusion where the linear rail goes. I haven't physically mounted it yet, but it fit in perfect. And I did my testing with the same G-code that we had before, and it fixed the cooling issues. This was before I'd got the high flow PLA. So that's to the point where we're pretty much up to date now. And I've spent the last few days tuning and pushing this high flow PLA as far as I could. So we've got to a point where I've got a 20-minute benchy, and then I did an 18-minute benchy, and I was seeing how far I could push it on that. But the benchy that we're printing at the minute is round about 18 minutes, and it looks perfect considering how fast it's printing. I am so happy with the results, and I need to find a way to permanently mount the auxiliary fan on the printer. The last kind of tweaking that I did was with Orca Slicer so that I could turn on the auxiliary fan. As default, it's sending out an M106P2 command, which is Marlin, and Clipper doesn't understand what to do with that. Clipper has a separate command which is to turn on a fan with the fan name Ox, and it didn't understand M106P2. If you send M106, it just turns on the part cooling fan. So working with the guys on the Clipper Discord, I wrote a little script which rewrites the M106 command and allows me to turn on whatever fan I want depending on what comes in, and then it passes the speed through. So in Orca Slicer, we can tell it that we have an auxiliary part cooling fan, and we can turn it on or off as and when we want to. And that's what we're doing, and it worked perfectly. So I'm sure that you've noticed that the benchy has been printing in the background, and we are almost finished. It's just doing the chimney stack now, and it looks fantastic. So as soon as it's finished, we will get it off the build plate and we'll have a closer look. You can see that the bow looks fantastic. There's no real issues around the windows, which is normally a bad point on the benches. And for an 18-19 minute benchy, I am sure you will agree, it looks perfect, just as good as any benchy printed on any printer in 1 hour 20 minutes. No issues on the bow. We don't have that line that runs across the side. the material has a constant black colour. We're not seeing a banding as it's printing faster and slower. Overall, a very, very good quality 20-minute benchy. So there we go. That was all about THICC, as I've called him, the TinyM 3D printer that is loosely based on a Voron 0. Thank you for watching. I hope you enjoyed that. Projects still going on in the background. The next big project is getting very close. I've got almost all the parts. I've got pretty much everything now. It's just 1 or 2 parts that are arriving. I did have to take a break. I had an operation and it took a bit of time to recover. So a few things are a bit delayed. But I really wanted to get a video out showing what I've been doing recently. Like I said at the very beginning, basically what I do in my workshop is whatever I'm currently obsessed with. And my general hobby at the time is 3D printers. Not so much 3D printing, but 3D printers and building them and tuning them and just learning more about them and how they work. I just love it. It's such a great hobby. And then when you can bring in all of your maker skills on top, make your own printers, it's just so rewarding. So I'm really enjoying it. And hopefully the next video will be the big one that I've been working on for about 3 months now. So I'll see you very soon. Thanks. Bye.